All right, for the last part of this discussion for patterns and nonlinear functions, this time what we will be doing is to write a rule to describe a nonlinear function. So let's say you are given ordered pairs. So you have 1, 2, 2, 4, 3, 8, 4, 16, 5, 32. What is a rule that can represent this function? So here it's like, what will be an equation that we can use so that for every input that we have, so our input is 1, 2, 3, 4, and 5, the output, the result will be 2, 4, 8, 16, and 32. Okay? All right, so let's first take into consideration the first ordered pair. So remember our input, those are our x values, and our y values would be, so we have 1, 2, 3, 4, and 5. So input is 1, the result is 2, 4, 8, 16, 32. So let's start with the first set of values. So if our x is 1, how can we make it become a 2? Okay, so there are multiple ways that we can do that, okay? For us to get a 2, it could be x plus 1, correct? So if our x is 1, 1 plus 1, that's equal to 2, correct? It could also be 2 times 1. So 2 times x, if our x is 1, that's gonna be 2, okay? We can also use exponents, all right? So we can have exponent, this time is the x. So 2 raised to the first power, so 2 raised to x, I should say, is going to be, so 2 raised to the first power, that's gonna be equal to 2, all right? So to figure out those different types of rules, you have to be creative and you have to like justify a way on how you can get from the input, which is x, okay? What can you do to that value so that you can come up with this output? Because that's the requirement, okay? So we have 3 choices here. We have an x plus 1, a 2 times x, okay? If our input is 1. And if our input is, if our expression is 2 raised to x, that could be also a possibility. So which of those 3 is the actual rule? Well, remember, we have a set of values in here, and so we have to try each of them and see which of those 3 options works with any of this other pair of numbers, okay? So let's try this next output and input. So let's have 2 and 4, okay? So with 2 and 4, if you have an x equals to 2, if this is 2, okay, if we have the x plus 1, it will be 2 plus 1 is equal to 3. Now, is 3 our output? Definitely not. So our x plus 1 rule will not work, okay? That's how you can eliminate that. So now let's try the next one. 2 times x, okay? So 2, and our input is, again, x is equal to 2. Is that equal to our output, which is 4? Oh, okay, looks the same. So this is still a possibility, all right? Now, let's have our next option. We have 2 raised to the x, okay? Our input now will become 2. 2 to the second power, is that going to be equal to 4? Yep. Okay, so out of the 3 initial choices that we have, okay, we are now down to 2, okay? So do you think we can make a decision already after the third pair of ordered pair, I should say? Most likely than not, yes, okay? So now we are down to 2 choices. So how do we know which one is which? Well, we need to try it out. So this time our input now is 3, okay? So remember, our x plus 1 is already gone. You don't need that anymore. So now we try out our 2 times x, okay? So if our input is 3, it should be 2 times 3. Is this equal to 8? Because that's our output here. Unfortunately, it's not. Okay, so the 2 raised to 2 times x is not going to be our rule. Now we try our last option, 2 raised to x. Okay, we have 2 raised to our x value, which is 3, is 2 to the third power equals to 8. Yes. Okay, so by the looks of it, the function rule for this data set would be 2 raised to the x power. Okay, and so you can try and prove to see if 2 raised to the x power can satisfy the remaining set of data here. So 2 raised to the fourth power, is that going to be equal to 16? Yes, it is. 2 raised to the fifth power, is it going to be 32? Yes, it is. And so these ordered pairs can be represented, okay, by a function rule. Where's my pen? So our function rule will be y. The value of the y will always be 2 raised to whatever input you have. Okay. So I would like you to try this next example, pretty much the same as what we did earlier. I would like you to try and figure out a function rule that could represent this data set. Go ahead, try this one out. So if you try to look at the relationship between x and y, how can you make x become the output y? So you have several options here. You have x plus 0, so 1 plus 0 is equal to 1. You can also get a 1 from 1 if you have like a 2x minus 1, right? So 2 times 1, which is 2, minus 1, you get a 1, okay? Another possible option would be x squared. So 1 squared is equal to 1. Now, once you have identified possible ways on how you can get the output using the first type of input, then you can apply the second input, try it out with all the possibilities that you have thought about, and you can eliminate which ones cannot work with it. So as you can see, x plus 0 won't work with the first one. With the second input, 2x minus 1 will also not work with the second input, and eventually you will realize that all of these numbers x, all this number x, if you square them, you will always get the y value. And so the rule, our function rule for this would be y is equal to x squared. So to summarize, just like linear functions, nonlinear functions can be represented using words, tables, equations, sets of ordered pairs, and of course, graphs. Thank you.